Okay, and continuing with stoichiometry, the steps to a stoichiometric calculation are as follows. Okay, I take the mass of A, and A is going to be the one that they give you the mass of, okay, times conversion factor. Well, this is technically not correct. This is going to be divided by the molar mass of A, okay. Conversion factor of mole A to mole B, so I'm going to put moles of B over moles of A, and conversion factor from moles to grams, which again is the molar fraction. But this time I'm going to multiply by the molar mass of B. So that's the process. 3 steps to go from these two things. So this is given, and this is the answer. Okay? And you got 3 steps. This one's step 1, to divide by the molar mass of A. Step B is the conversion factor from A to B. So B goes on top and A goes on the bottom. So what you want to find is always on top. What you're coming from is always on the bottom. Times, then the last one is conversion from moles to grams, which is the molar mass of B. Okay, so I have, oops, that was interesting. Okay, all right. So I have animations that kind of go over that. So here's a reaction. Ethanol, this was the reaction we just did on the last video, plus 3 oxygens goes to form 2 carbon dioxides plus 3 waters. Okay, I'm arbitrarily going to say that A is carbon dioxide and B is oxygen. It could be any compound, and this could be A, any compound, and this could be B. A and B can't be the same compound. Okay, so step 1 is take the mass of the carbon dioxide, because that's A, divide by 44.01. This is the molar mass of, oops, crap, I don't know what I just did, of CO2. Okay, so that's step 1. And when I do that, I get moles of carbon dioxide. Okay, so mass divided by molar mass is moles. Okay, step 2 is to do the conversion factor. Okay, so this 3 came from that coefficient. This 2 came from that coefficient. So that's where you get the numbers from there. Okay, and when I do that, I end up with moles of oxygen. And step 3 is to go from moles of oxygen to the conversion factor from moles to grams, so I need to use the molar mass. So step 3 is I take the moles of oxygen times, again, this again is the molar mass of O2. And my answer is the mass of O2. So let's do this with real numbers this time. Okay. So I have problem 84 in the book. It says white phosphorus is prepared by fusing calcium phosphate, and this is the formula for calcium phosphate, with carbon, that's the formula, sand, which is silicon dioxide, and electric furnace. So this is the balanced reaction. 2 calcium phosphates plus 6 silicon dioxides plus 10 carbons goes to form 1 white phosphorus plus 6 calcium silicates, ITE, plus 10 carbon monoxides. So the question says, how many grams of calcium phosphate? So this is my B right here. So this is what they want to know. So this is B, X grams is B, is required to give 30 grams of phosphorus. So this 30 grams here is A. Okay, so the one they give you the mass of is A. The one you're seeking is B. So I'm going to do the same. Now, in order to do this, I had, in the last problem, I had molar masses. So, well, first of all, let me write out the information. So I have 30.0 grams of P4. What I want is X grams of Ca3, PO4. Okay, and you saw from the last one, I need the molar mass. So the molar mass of P4, and I did this just like I've done all the other ones, 4 times the 30.97 is 123.88. Okay, and the molar mass of Ca3, PO4, 2. Again, this is 3 times the 40.08 for calcium, 2 times the 30.97 for phosphorus, the 8 times 16 for oxygen. So I get 310.88 grams per mole. So those are just the number of atoms times its atomic weight. So step 1 is to take the mass given, so 30.0 grams, divided by the atomic molar mass, which is 123.88, and I'm given 0.2422 moles of P4. Okay. Step 2 is to do the mole-to-mole ratio, so I start with 0.2422 moles times, okay, I have a coefficient of 1 here, but does this go on the top or the bottom? I should have written down P4 there. It goes on the bottom because I want to cancel it, so 1 mole of P4 on the bottom, and the 2 here goes on top, so 2 moles of the Ca3 PO4 2. Okay, and I've said it before and I'll say it again. If I write this out, it's important. Okay, and so that gives me 0.4843, and the reason it's not 44 is because in my calculator I don't actually round it at all. So this is moles of Ca3 PO4. If you have 4 here, I won't count it wrong. And step 3 is take the moles of calcium phosphate, so 0.4843 moles of Ca3 PO4 times its molar mass, which is 310.88 grams per mole, and I get 150.2 grams of Ca3 PO4 2 of calcium phosphate. And technically I would only need to have the 150 because typically my answer has 3 significant figures. This has 3 significant figures to start with. I just wrote down 4, but 150 is also perfectly acceptable. 200 is not acceptable. That's rounding too much. Okay? And so that is the end of this video.